Right. Yes. Yeah. Thank you. So, in the last class, audible? All right. In the last class, we were talking about the applications of evening class. See, there is an evening session with respect to only mains orientation. Okay, that I will know the details in complete and will post you. So for the time being, we will look at this aspect of space applications, which we have been seeing all these things. The last topic which we did was blank space, only space is there. Yeah. So we were looking at how different, these are the things which we did till now, very quick revision, type of launch vehicles, need for two types of launch vehicles. So when we are looking at this aspect, don't think that here I'm not counting. Some of the students are asking the doubts with respect to speeds. If you look at this red color marked geostationary orbit here, it's not that only one, this is the only speed available. If different orbits in geosynchronous also will have different speeds. In geosynchronous orbit also, if the orbit is nearer to the Earth, speed will be high. Okay, but here the issue is in polar orbit, when it is going pole to pole it is going. Earth is also rotating. There is a different way in which we can cover the whole Earth, line by line, line by line, line by line. Okay, so that's the reason with respect to national resource management, with respect to disaster management, it has its own applications. With respect to roads, with respect to remote sensing, different applications can be developed. Finally, we are looking at, not finally, we look at type of satellite launch vehicles. We look at the stages of all these satellite launch vehicles, 4 places where Vikas engine is used. Yes or no? With respect to different type of fuels which are being used. Yes or no? Just the names you have to know. Type of fuels which you have used, only the names only we have to know, not the chemical composition of it. And to know this hydroxyl terminated polybutadiene itself is next till now it has not been asked. Okay, just one step ahead. Just to know it's not naphthalene balls we are using some STBT. Fuel volcano, we have to know a very brief manner. Look at the difference between strap-on motors in GSLV Mark II and GSLV Mark III. All these are the things. Then we are talking about reusable launch vehicles. Then we talked about space capsule recovery. Then we saw air breathing propulsion. We saw the applications of ISRO, the socio-economic development of the country. This is the manner in which we now we will look at some of the aspects, some developments, especially with respect to communication technologies. A transponder is a device which will carry these communication signals. Generally, these transponders will be available in which type of satellites? Communication. It is the actual receiver which receives the signals and sends it to the transponders are present in communication satellite. Communication satellite carry these transponders with them. Then with these things, they will be rotating around the Earth. We will be sending the signals and receiving the signals, establishing our mobile communications or defense secure communication lines. All this. Now, when we are sending signals, that is form of light energy. Yes or no? Light is visible light, but light is also a form of electromagnetic energy, wave energy. What energy? Wave energy. Now, when a light is having like this, when we are calling it energy as a wave, it travels like this. Yes or no? Up and down, wave. Upper part is called crest, lower part is called trough. One wave means one crest, one trough. Now, this length, one crest plus one trough, is called wavelength. That length can be bigger or small. So when wavelength is small, it means what? Wavelength is small. It means wave is only like this. Yes or no? When wavelength is big, wave will be. Okay, I'm expecting you to imagine. I remove this as a board. Here I think I can draw a bench. Mike, let's see. See here, wave, when it is traveling like this is called as what? Wave. Okay. If it is having smaller wavelength, it will go like this. Yes or no? So here the wavelength is only this much. Here wavelength is small or big. So wavelength is the length of the wave in simple terms. Whereas frequency means number of waves passing through a particular point in 1 second, something like that. So wave is traveling like that. How many waves will pass through it in a time period? That is frequency. Number of waves passing. So if wavelength is high, frequency will be. Wavelength is high, a bigger wave, and number of waves passing through a particular point will be less or high. So once wavelength, we call it some symbol, frequency, whatever F. When this is high, this will be less. When frequency is less, wavelength is high. That much once you have to remember. Now, with respect to transponders, Earth is there, satellite is there, communication satellite have an instrument called transponders. Okay, from the transponder, I have to receive a signal which is being sent from the satellite. Now, the receiving antenna also will have size. It will have a bigger size or it will have a smaller size. Yes or no? Based on what? That is depending on this wave. If you have a bigger wavelength, you should have a bigger antenna. If you have a smaller wavelength, you should have a smaller. Simple logic. If the wavelength is big, means if frequency is small, antenna is big or small. Once upon a time, dish TV, before this DTH, the dish TV used to have a very big. In a particular village, one person will be maintaining that big dish. Through them, cabled wire will be there. Is that dish size big or small? Whereas, when we are using our own DTH, direct to home, Tata signal, Is it the antenna is smaller or bigger? Smaller, because they are using higher frequencies. Means they are using, simply put, lower wavelengths. So as different signals are used, different antennas will be used. Some particular frequencies are fixed for some applications. For a military application, this much frequencies. Either I can tell in terms of wavelength or I can discuss in terms of frequencies. Yes or no? Both should be remaining. One into other should remain constant. Forget about that physics. When wavelength varies, frequency varies. So I have to talk either in terms of wavelength or frequency. While talking size of the antennas, I will use wavelength term. While talking about applications, I will use frequency. 1G, 2G, different frequencies. Okay, military, different frequencies. Medical or civilian applications, different frequencies. Communication networks, different frequencies. Okay, so like that, they have divided the frequency band, C band, K band, K band, KU band, group of frequencies. Okay, so when mobile phones companies are coming and they are selling the frequencies, okay, they have the spectrum. You might have heard about spectrum. It means the government, the ISRO is sending these satellites. Those frequencies will be given to the buyer so that he can use it for mobile or any other communication applications. Okay, so 5G will have different frequencies. 2G will have different frequencies. Things will be auctioned. They are just like natural resources for the country. Okay, so who is enabling it? ISRO. TRAI is a regulator. Okay, ISRO. Without ISRO, what TRAI will do? Yes or no? Basic technology is provided by whom? ISRO. Okay, those banks, different banks will be auctioned and they will be used in different ways. So if you look at this transponder, it's a receive signals, it sends the signals like this being seen. See, Earth station you will have, satellite will have transponder, as you can see it. And just sending the signal, satellite will receive it, transponder, and it will send it back directly to the DTH receiver. Yes or no? So like that, it is being there. Satellite frequencies for different applications will be having different frequencies. If you look at the other edge, very low frequency, from very low frequency to very high frequency, this point. Generally, human applications are more in 3 gigahertz to 30 gigahertz frequency. Previously, radios use different frequencies. Okay, 98.4 FM, all these things, different frequencies. What is the radio station frequency? Depending on different frequencies, different radios. When both are merging, when interference is having, you will be doing your exercise radio. They will be talking about how to make chicken. Both will mix and you will do mix. So this kind of things will happen if frequencies can interfere. Anyway, different technologies are there to prevent it. Now, 3 gigahertz to 30 gigahertz in this band, satellite microwave telecommunications are more. For ship navigation, there are different. For maritime signals, there are different frequencies. For radio, they are different. For analog radio, for digital radio, different frequencies are there. General common sense application, 3 gigahertz to 30 gigahertz, that to different bands. L band, S band, C band, KU band, K band, K band. So question can come, which has highest frequency, K band or Ka band? This is highest. C band, K band, which has higher frequency? C band or K band, which has higher frequency? K. Only that much you have to. Depending on the size of the antenna also will be different. So L band, you see, it's not that you need not to remember all these things. L band for global position system. S band for radars, weather radars, subsurface radars, ship radars like this. C band, bigger dish. See, if you look at C band versus KU band, which is higher? C band or K band, which has high frequency? K band has high frequency, which has high wavelength. Previously, communications used to be on, they used to use land frequencies, high wave. That's the reason dish used to be very big. Now it is very small. In the future, different communication technologies will develop. Yes, it's generally required that you need to have at least 3 satellites for fixing a point. Look at the figure there. Look at the figure. How many satellites are generally required to pinpoint a location? 3. Generally, it is 3 which is being used. 3 satellite, I want to pinpoint a point. So 3 satellites will be minimum required from, if you point one location, other location also I can pinpoint with the 3 satellites, the distance navigation, how to go from this direction to that direction. So navigation technologies, not only your Google Map and the things which are being used here, varieties of applications are being developed. When we are saying these navigations, when we are talking about this navigational aspects here, the world has developed, some of the countries have developed their own specific navigation systems. GPS does not belong to India. Global position system, which we are using till now, belongs to US. They have designed it. Imagine the things before GPS. Did the countries survive without GPS? Yes, they survived. Even civilians also survived without GPS. Yes or no? They used to ask and go. Now nobody is asking anyone. Direct Google Map. A stage has come from home to tuition. Direction is not known. Without mobile phone, huge dependency on technology. Anyway, this GPS, now the problem comes with respect to GPS, when our own movement is being taken help, is being devised by taking help of other country, always there is the issue of security, safety and security. The data is very useful. Yes, sir. Sometimes military data, all this GPS, even suppose our airlines are using GPS. What if there is a technical snag in the GPS? Suddenly they limited that GPS to only US. Issue will come. Railways are used, tracking is used. Till now we are relied on GPS data. Okay, what if someone hacks GPS? Lot of issues can come. So in order to avoid all these things, in order to have our own thing, we have regional satellite navigation system, which is also called as NAVIC. What we are calling it? NAVIC. It is not a global position. USA is using 24 satellites and it is mapping the whole Earth through its GPS. If you go to France, you will have GPS. If you go to Australia, you will have GPS. Whereas India is not planning for global positioning system. We are only looking at regional aspect. India's regional satellite navigation system. Okay, so other examples are there. GPS, US governments, GLONASS belongs to Russia, Galileo belongs to European Union, Reddy belongs to China, the Swazi Zenith, Japan's regional thing, our own India's regional navigation satellite system, which is also called as what? So in the future, when things are happening, all our mobile phones will be made compatible with NAVIC. Now they are compatible with what? Already regulations are there. Slowly things will be aligned with respect to this. Now, before going into the next dimension, what are the applications of geospatial data. What is geospatial data? Where I am locating, how I am locating. With the help of this technology, what applications can be developed? That is the thing. Minimum 3 satellites are required to pinpoint a position. If you add 4th satellite, you will have your location with respect to height also. I am in which floor now? 3rd floor or 2nd floor? 2nd. If you have a 4th satellite, at least in this point, which floor I am in also can be. Third, only in Ola will be location will be shown. Will it tell floors? No. Okay, but as you go on adding satellites, dimensions will increase. Anyway, India's regional navigation satellite, it is using 7 satellites. How many satellites? 7 satellites for a whole network. This will cover up to 1500 kilometers outside India's border. 1500 kilometers means, will it cover Beijing? Will it cover USA? That much you have. Already they asked this in UPSC. Outside India's boundaries, our own Indian regional navigation satellite system will cover up to 1500 kilometers. Beijing is about 3000 kilometers. Okay, so this and our neighbors up to 1500 kilometers, the navigation service will be obtained, will be available by using our India's own map. Now the question is, what are the applications of this geospatial technologies? What ways can be developed? Can you imagine a day without geospatial data? Can you require geospatial data? If you want to go to a hotel, you want geospatial data. If you want to look at rivers in a particular region, you want geospatial data. Yes or no? So geospatial data has enabled a lot of business applications also. There is no app-based applications, app-based economy. Swiggy is there. This Zomato is there. All these things, without this geospatial data, is it possible? No. Yes, sir. So varieties of applications are there with the help of geospatial things. So before me telling the applications, I want you to work out, write a question now, discuss the applications of geospatial data in Indian context. Discuss the applications of geospatial data in Indian context. 2 minutes. Try to list out various applications which can be developed using this technology. Okay. Try to write the applications. Highlight the various applications of GPS, global positioning systems. Yeah. Please try to see here. You might have written some of the applications. Coming back to our own India's NAVIC. India's NAVIC, which is also called Regional Navigational System. Okay. It will give two types of services. One is standard positioning service, other is restricted service. This restricted service is only for authorized users. Okay, general civilian applications will coming on point number one, standard positioning services for all users. That's it. But generally, this restricted service, it's more military applications, specialized users will use. So we look at when we are talking about these applications, we'll list out in varieties of dimensions in which this data is used. The services are IRNSS. It will provide accuracy up to 20 meters. How much? 20 meters accuracy will be there. So you can pinpoint a person or an object or anything location up to accuracy of how many meters? 20 meters accuracy, not in GPS. I'm talking about our own nav. So it has varieties of applications, navigation, not only with respect to terrestrial, aerial navigation, marine navigation. Then disaster management. In the event of disaster management, how to mobilize people, how to move people from one point to point A to point B. District collectors they might have to move even 10 lakhs people. Not only movement of people with respect to movement of resources, movement of animals, movement of biodiversity. All these things data is very important in disaster management. What are the various assets which are under threat? What are the locations of hospitals, locations of fire stations? All this data is very important for disaster management. Yes or no? So that this is the dimension. Then vehicle tracking, fleet management, your vehicle, not only with respect to your cars with installed of this GPS device, not only that, with respect to suppose you have APS RTC, sorry, or any railway or any RTC, bus movements, fleet management, where are they, how they are located, all these things are there. Integration with mobile phones, all the GPS data or our remote sensing data can be integrated with your smartphones. Precise timing, how much time the simple Ola will tell you. If you have taken the cab, it will tell you at what time you are reaching. Almost it would be accurate. Maybe if something inadvertent happens in between, irrespective of that, it will calculate signals, it will calculate traffic density, and it will give you a plan. Timing precision can be maintained with respect to this data. Mapping, data capture, varieties of mapping. Mapping itself is very high. When we are calling it mapping, I'm not talking only about boundaries. I'm talking about maps with respect to canals, with respect to state boundaries, taluk boundaries, mandal boundaries. Not only that, village, community resources. In huge manner we can. Terrestrial navigation for tourism, travelers. Without your Google Maps, imagine if you are driving, going for a travel trip. Difficult. Yes or no? So like that, visual and voice navigation for drivers also. So a lot of navigational applications are there. So brief applications directly from Wistro website. I have taken this snapshot. These are the ways in which we can use this NAVIC. Now coming to NAVIC, if you look at India's NAVIC system, how it is being established, they have used 7 satellites. How many satellites? 7 satellites. Previously, I was talking about 4 satellites. The intention of the 4 satellites is at a particular point, minimum how many things are required. That 4 satellites, a satellite can cover a very vast region also. So to cover India, they have used how many satellites? 7 satellites. If you see the picture here, 3 satellites are black. They are not black actually. In the figure, 3 black colored things are in which orbit? Geostationary orbit. The remaining 4 you will find in geosynchronous. 3 in geostationary, 4 in geosynchronous. That is the combination with these 7 satellites used in India's NAVIC. Actually, 8 launches have been taken. And in the first launch, the atomic clock, timing, GPS wants timing, IRS wants, our remote navigation wants, Navig wants timing. That got failure. So another satellite mission they launched it to fill that gap. Total 8 launches, but how many satellites? 7 satellites, 3 in geostationary, 4 in geosynchronous. Anything in polar orbit. Okay, so our Navig is based on geostationary and geosynchronous because we are looking at a particular, we have to look only at India. Na? There is no point in looking at other places. We want to look at India. So geostationary in all the ways and geosynchronous things. You look at the picture also that is focused based on only on India and the surrounding 15-kilometer region. So this is India's Navig. They have designed it like this. America has 24. IRS has up to the range will be up to 1500 kilometers. 4, 3. Okay. Then coming to this thing anyway visit, don't confuse with another term which is in the news, which is called Gagan. Gagan is different. When we are talking about our Navig system, Gagan is only designed, specifically designed for aviation. It is not using the same satellites. Actually, if you look at the satellites of Gagan, it is using 3. DSAT 50 is also launched. DSAT 8, DSAT 10, and DSAT 50. This is different from 7 satellites of Navig. They are separate 7 satellites. Gagan is only meant for GPS aided geo-augmented navigation. This is developed by Airport Authority of India and ISRO to provide navigation facilities for civil and military aviation, particularly with respect to civil aviation. The area covered by Gagan is much more higher because aeroplanes will go at very huge distances. Yes or no? They are covering from Africa to Australia. The scope of Gagan is to cover from to Australia, especially for aviation sector. But also it can be also used for maritime sector also. Shipping industry also will use this. So don't confuse Gagan as a sub-component of Navig. Navig is different. Gagan is different. That's what. Satellites are also different. GSAT satellites are used in Gagan. GSAT, what are the satellites? GSAT 8, 10, and 50. Okay. So this is a small topic is there with respect to sounding rockets. Sounding rockets are initially used for weather, studying weather, lower areas, atmospheric studies. ISRO began its work with the sounding rockets only by launching from Trivandrum, Tirunanthapuram, various sounding rockets. It has launched 1963. Now our whole sounding rocket system is been integrated under Rohini. Rohini rock system of rockets are not satellite, are not communication satellites, are not remote sending. They are what? Sounding rockets for collecting atmospheric weather data, meteorology, and all those things. Different ranges are there. There are different Rohini versions are there. Rohini 200, 300, 560 Mark II. It just carries certain devices with it. Look at how much small size it is. It just carries it. Somewhere sometimes can keep a balloon there in the atmosphere about 10 kilometers, 20 kilometers, send the data. All that weather meteorological information can be obtained. Now, very important mission. Discuss briefly about Chandrayaan. Okay, UPSC will not ask questions because we are not theoretically bent. But some aspects we have to know, at least in the context of prelims or for the sake of analysis, we have to know at least what is being done. Now, why there is renewed interest on moon? That is question number 1. Apollo missions by NASA were done in which year? 1960s. From 1968 to 72, we have Mars missions. Sorry, moon missions. Why? After a big break, why we are focusing now on moon? That is one dimension which we have to understand. Second aspect is with respect to Chandrayaan. How the mission is being done, what is its significance, what is the data or what are the payloads in Chandrayaan 1, how much we have. What are the payloads carried by? What does it carry? What did it carry? What are the achievements of this mission? Only these two key dimensions we have. As I said before, Chandrayaan-1 used PSLV or CSLV? PSLV. Now, in order to launch Chandrayaan, or in order to reach the moon mission, let's say, we can launch it. See, this is Earth here. Somewhere else we have moon. Yes or no? We want to launch a satellite which will go and rotate around moon. This is Chandrayaan-1. So in order to launch it, I can take a PSLV. Simply I will go point A to point B. That is one method. We have to launch a satellite which will roam around moon. So we will take, we have a launch pad, we have launch vehicles, we will take GSLV or PSLV, directly we will go. This is method 1, which is not at all used. Why? Because we don't have enough fuel. The distance is in lakhs of kilometers, sometimes 4 lakh kilometers, sometimes it goes. The distance between Earth and Moon also will vary continuously. Average 3.8 lakh kilometers. Now, as on in December, it is around 3.8 lakh kilometers. Whereas satellites, we are talking about how many hundreds? 200, 300 kilometers, 400 kilometers, or geostationary at the max, we are talking about 6,000 kilometers. It is in lakhs. The distance are in lakhs. Fuel is not sufficient. So we are using a different methodology. You see that. I'll come back to this. You see the picture in which the Chandrayaan-1 mission was taken. Now, if you see this picture, in the initial steps, only launch vehicle will launch it in an orbit around Earth only, like this. Yes or no? Slowly, this vehicle, if you see, this is PSLV. Yes or no? Are you able to identify the launch vehicle? Red color one, PSLV. That is gone. Only Chandrayaan-1 satellite payload is here now, which is actually traveling towards the. So the main fuel or the main stages of the PSLV are spent. Only this orbit is launched. Then slowly, small variation, it will inject, it will start its motors. Slowly, it will change the path, and it is going nearer to the increasing this orbits. Because within the orbit, we don't require much fuel. In order to maintain it, because gravity is there, that is balanced with the speed, slowly to next orbit, small change of motors is required. It will go to the next stage. Like that, it will increase the orbit. Finally, the motor will start here. It will travel. When it is enough distance, it is reached, then it will go and it will get inserted into the gravitational force of light. That's the reason it does not have any stages. There is no rocket launch vehicle here. Only Chandrayaan-1 payload is there. Now, Chandrayaan-1, its intention, if you have to see, Chandrayaan-1 was intended to study Earth's, like Earth, what is the composition, what is the topography of Moon? It wanted to study it. So the initial plan of Chandrayaan was to launch just an orbiter around the Moon. Suppose this is Moon here. We have Moon here. The initial interest was to just launch this is Moon now. Initial interest was to launch a orbiter around Moon at a distance of how many kilometers? 100 kilometers. Which orbit? Polar orbit. I'm drawing it like this, but actually it is what? Polar orbit around the Moon. At what distance? 100 kilometer distance. It will be rotating pole to pole of Moon. Then our study about its surface, its mineral composition, its radiation, whatever it is there, its atmosphere, collect data, spectroscopy will be there. It will collect the data from the emitted light from that and it will send the data. Okay, but at the point of time, it was done in 2008. Abdul Kalam was there. He also talked, when we are going so far, why can't we go and hit it? At least touch it now. You are going so far. At least touch it. So ISRO has changed it. It has added another payload in it called Moon Impact Probe. What is it called? Moon Impact Probe. Where it will just go, it will have a small measuring instrument. The Chandrayaan-1 will be revolving around the moon. Once the orbit got stabilized, it will release this Moon Impact Probe. It will go and hit the moon's surface carrying India's flag. Yes, our flag is there now. Okay, on the moon. India's flag is there on the moon through this Moon Impact Probe. Now, when it is going and just hitting it, it will have some sensors. Slowly, it will collect some data, whatever is possible. Okay, so don't, rather than going and having this, let's touch it. In the next stage, we will send a rover which will go and travel on the. Okay, so this was the purpose of Chandrayaan-1. Which year? 2008. We look at here, it is done in 2008. This is the P. To roll around, to revolve around, to rotate around, how much distance? 100 kilometers around. Why this renewed interest? Because if you see here, some of the important things are there with respect to moon. There is a material called helium-3, isotope of helium, which is very useful in nuclear fusion. When I'm talking about fusion, one nucleus will merge with other nucleus and create a third one, combined one. This process is called what? Nuclear fusion. Earth is a star because of which reaction? Nuclear fusion reaction. Hydrogen fuel is there. When that fuel is exhausted in sun, will the sun, I'm talking about sun actually. When fuel in the sun is gone, when hydrogen fuel in the sun is exhausted, will the sun stay? No, it will collapse. Okay, so how we can use nuclear fusion? Moon has this element called helium-3. So we want to study about it. Then with respect to future space exploration, first we have to go to moon if you want to travel to Mars or further. First you have to clarify prelims in order to go to mains. But mains preparation should start well in advance. Yes or no? Because between prelims and mains you will only have 3 months. You have to cover optional, you have to do many things. This is a strategy. In the same way, moon is an experiment for that. Okay, so there are many new ways of understanding how Earth got created. Because there is a theory which says that moon got separated from Earth. Origins of the moon will give us insights into origins of Earth. So these are some of the reasons for renewing interesting on why we are focusing on moon now. So Chandrayaan-1 has 11 scientific instruments. Yes or no? So in that 11, India has 5. Other countries have, these are the countries which were involved to just giving the payloads done completely by India, but these are the only payloads. Bulgaria has also given its instrument to carry it with Chandrayaan-1. So after rotating around the moon for around a few months in 100 kilometers orbit, we have raised the orbit to 200 kilometers in order to study its atmosphere and other further studies. So while this Chandrayaan-1, after orbiting around the moon in an orbit of 100 kilometers, the orbit was raised from 100 kilometers to 200 kilometers. So when this was happening, the temperature estimation was incorrect. Some devices in Chandrayaan-1 got burned. The mission got aborted later. As of now, we don't have any contact with Chandrayaan-1. But all these months, it was intended for 2 years mission, but it was less than 1 year. 90% of the data already it has collected. It has made some achievements. What is the achievements of Chandrayaan-1? That also we have to see. But we will see anyway. Scientific payloads from India. How many payloads from India? 5 are there. Terrain mapping camera, hyperspectral imager. These 5 are the payloads from India. Terrain mapping camera, images, spectrometer instrument. Spectrometer will analyze the radiation, light, or anything which is coming, and it will know about the materials which the moon is having. What is the content of Pluto? We have some estimates. How do we know that Pluto has these minerals? Because these minerals will radiate energy. That energy will be analyzed. Radiation will be analyzed. Like the spectrometer also will, with the help of spectrometer, we will know the composition of the materials. So we'll have a lot of spectrometers here. Then finally, I was talking about this moon impact. All these 5 are from India. Rest of the other countries gave this Chandrayaan-1 spec. See how many spectrometers you have. Spectrometer, this synthetic aperture radar, mineralogy mapper, radon, radiation dose monitor. All these others are from countries, USA, UK, Bulgaria. Other countries gave this. We carried total how many? 11 instruments. This is not important much, but this is important. These 5 things which was carried by India is important. Then comes moon impact probe struck. What are the achievements of Chandrayaan? This is it. Okay, water was discovered. Presence of water in lunar soil. Okay, so this is the important discovery from Chandrayaan. Water ice, that will especially at the south pole of the moon. Not only that, I'll just think water vapor was discovered. It confirmed ocean magma hypothesis. What did it confirm? Ocean magma hypothesis. It means once upon a time, moon was full of, with respect to Earth or moon was once in the form of molten shape. Molten, it was having high temperature. That hypothesis was confirmed with Chandrayaan-1 data. It also finds many minerals. Moon has all these minerals, magnesium, aluminum, silicon, calcium, all this. Avatar movie is happening. Yes or no? So we want to explore minerals outside Earth also. It has discovered new types of materials, new spinner. It is a magnesium compound. New types of rocks are also found on Moon. All these are the achievements of all Chandrayaan. Okay, 3 or 4 traces of water, ocean magma hypothesis, spectrometer X-ray analysis has given these kind of elements, and new type of rocks. New types of rocks are also discovered on Moon's surface. Okay, then comes, I said, with respect to Chandrayaan-1, after this 100 kilometer orbit, it went to 200 kilometer orbit. There was a technical error. The contact with Chandrayaan-1 was lost. In Chandrayaan-2, the purpose of Chandrayaan-2 now is to have a lander and rover. 3 things are there. Orbiter means it will orbit around the moon. In a particular orbit, just like a satellite, it will be moving around the moon. Whereas with respect to lander, a device, an instrument will go and land on the surface of the moon. Rover will come out and move the surface. 3 things are there in Chandrayaan-2. Orbiter, lander, rover. What happened with the Chandrayaan-2 was, with respect to Chandrayaan-2, they have successfully launched the orbiter. It is a successful. Still it is, as on today, still it is going around the didn't lost contact. In October 2022, Mangalyaan lost. Mangalyaan was launched in 2013. Okay, so we lost contact with Mangalyaan. So Chandrayaan-2 is still okay. So what was happening was orbiter was launched at the same time when this lander was about to land on the surface of the moon. We lost the prime. You might have seen that visuals. Prime Minister was there, ISRO chairman was there. He was consoling this because just about to land. Rather than soft landing means controlled manner without causing any destruction or trouble. It has just crashed land. We lost the contact with both rover as well as. So in order to, still it is sending data. Chandrayaan-2 is still sending data. So in order to go for the next stage, Chandrayaan-3 is planned. Actually, it might have done till now, but COVID has disrupted, they say. They are telling COVID has disrupted Gaganyaan, COVID had disrupted Chandrayaan 3. But Chandrayaan 3 is being planned without the orbiter. Because orbiter is there in Chandrayaan 2. You have to concentrate because I'm not using the board. Describe it here. You have to focus on what I'm telling. Otherwise, nothing will go. You will happily sleep. Okay, things will be like a good melody, boring melody. You will Chandrayaan. Where are we, Chandrayaan? Okay, so like they try to focus what is happening here. In Chandrayaan 3, we will be sending only lander and rover. Why? Because that is the failure of Chandrayaan 2, and Chandrayaan 2 orbiter is still there. So in Chandrayaan 3, only lander and rover will be planned, and it will use the existing Chandrayaan 2 orbiter to send us the whole focus becomes is now on the thing, on the aspect which we are unable to do in Chandrayaan. Will happen in the future, more details will happen. Here also, if you see the orbit here, same thing. Chandrayaan 2 also, GSLV has been used. If you see it here, it is going orbit. Look at the orbit. Slowly it will be launched here, vehicle will be one, then only the payload will be there. Slowly it is increasing the orbits, one after the other, one after the other. When it reaches nearer to the moon, it just switches and comes into the gravitational force of the moon. Slowly becomes around 100 kilometer height will be maintained. Chandrayaan 2. As I said, three things are used: orbiter, lander, rover. Orbiter is named as, orbiter is not named, Chandrayaan 2 orbiter only. Lander is named as Vikram. Rover is named as Reddy. What is the launch vehicle? Not PSLV. GSLV Mark 3. GSLV Mark 3. Okay. So this is about Chandrayaan 2. Payloads are, what are the significance of Chandrayaan 2? What did Chandrayaan 2 achieve? That is also briefly you have to know. Detected solar proton events, imaged a crater. We named that crater as Sarabhai crater. We discovered a organ 40 on lunar surface. We discovered hydroxyl water molecules also. Precision. With precision we have detected. So water, next step. With new material, new protons, new type of solar interactions we detected. Craters we imaged. New elements also we have discovered with respect to Chandrayaan. Okay, what is it? What is its achievement? Only that is done. Chandrayaan 3 orbiter will be used. Same orbiter of Chandrayaan 2 will be used in Chandrayaan 3. Okay, lander and rover, when they are launching, that will be having. This is the images. Sorry, these are the payloads which are planned to be carried on Chandrayaan 3. Anyway, let it happen, then more details will come. Then a very quick review of Mars orbiter mission. It also will be being used by PSLV. What is the launch vehicle for Mars orbiter mission? PSLV. 2013, we don't have GSLV. It is the fourth country. ISRO became fourth space agency to successfully send a spacecraft to Mars. There are many fourths for ISRO. Fourth country to launch the spacecraft to moon also. Fourth thing to this Mars orbiter mission also. ISRO, unlike ISRO, NASA has many failures. ISRO was able to do it in first attempt itself. Okay, both with respect to moon as well as with respect to Mars. So Mars, Chandrayaan, Mangalyaan also we have. Details are not much. We are studying this. These are the payloads with respect to Mangalyaan. For UPSC, it's not required much. Not stellar camera, photometer, methane sensor. Wherever we are going, we want methane or water. Why? Because anaerobic oxidation, anything will happen. Life will be there in this manner. So we are searching for these things. Many images are there. We just lost contact with mom. Okay, we did this with only how much cost? 450 crores, which is very less. When compared to other nations, this is a very less cost. Okay, so we are not wasting our resources. We are efficiently using it. That itself is a very big. Now, this is the question which I have asked. India has done all these things. With respect to, look at this question, please look at this question, write down this question. India has achieved remarkable success in unmanned space missions. India has achieved remarkable success in these things. Till now, why don't we have, but not ventured into manned space missions, both in terms of technology and logistics? Please explain this. Try to think on this for 2 minutes. Taken down the question. I'm just taking away. There is some error here. Please try to do that. No discussion, right? when we have done space exploration missions, why human space program is so late? We are planning Gaganyaan, fine, but why not human space mission till now? Gaganyaan is planned. So why till now? Answer I have already given. Only think on the things which are discussed in the classroom till now. First part of the question, answer of that question would be primary focus would be on national development. That's the reason we didn't venture into human space flights directly. First, let us complete the application oriented, national development oriented areas. That's the reason ISRO focused on its resources on national development goals. Then comes after achieving the threshold, then we are focusing on stage by stage, Chandrayaan, Mangalyaan. Then later we are looking at human space flight. But the question is already talking about with reference to Mangalyaan and Chandrayaan. When Mangalyaan and Chandrayaan is there, why not Gaganyaan? The thing is, in order to do human space flight, we require some technologies which are not there. Do you have a reusable vehicle? We'll just send the astronauts, sir. Bye, Tata. Send us data. Your life, you contributed for us. We don't have a reusable launch vehicle. We don't have crew capsule recovery. We don't have microgravity experiments because in the satellite around the Earth, gravity will be almost zero. On the surface of the planet or here, can you tell me experiment micro or you will feel this phenomena in 1 or 2 milliseconds, you will feel this. Microgravity in your day-to-day life, where you will feel this when it is starting and when it is stopping. Common sense answers. Yes, sir. So in the where because the forces will be balanced, machine will be pulling, earth will be pulling, some balance will be there. Okay. That balance is there continuously on satellite. So within the satellite orbit, imagine that this room is there, which is rotating around the Earth in an orbit. It will always will be sitting like this or what? It will be floating because gravity is almost zero. We have to create that environment on there. We have to train the astronauts for. Even today, for Gaganyaan, we are taking the help of other countries. Obviously, Russia. Yes or no? So we don't have the technology, we don't have microgravity technology, we don't have space capsule recovery, we don't have reusable launch vehicle. That's the reason we are not venturing into human space. First part of the question should be answering on our development. Second area should be focusing on technical aspect which we are lacking for creating human space program. So in order to have this troubles, we now are focusing on this human space program. Fine. India is doing it under which name? Gaganyaan. Okay, we'll quickly see the details of it. So this is happening. People are able to see, but some other screen is being projected for the display.
Shall we close the showing some error like closing annotations.
Okay. See, try to listen. We'll close it now in 5 minutes. There are some technical errors here. With respect to Gaganyaan, so India is now focusing on which aspect? One of the important missions now is to focus on human space. India's Gaganyaan will happen in 3 stages. Okay, in 3 levels. First, they will send an unmanned thing. Then they will send a robot. Mitra. Robot will be there. It is an autonomous robot, humanoid robot. They will see the conditions. In the first flight, we will just recover the capsule. In the second Gaganyaan, we will send this robot. It will be various conditions, whether human beings are suitable there with our technologies that we will test on this humanoid robot. Then in the third stage of Gaganyaan, actual humans will, okay, 3 or 4 humans will be going with respect to India's Gaganyaan mission. Already they are being trained. Many organizations are involved. Pilots are being trained in microgravity modules and all those things. So India's Gaganyaan, what is the significance of India's Gaganyaan? What is the utility of Gaganyaan mission? That is the only requirement which we have to see. Purpose kya hai Gaganyaan mission ka? It is happening in 3 stages. What are the advantages or benefits which will be having by conducting this Gaganyaan mission? One thing is definitely it is a high-end technological feat. It will have various impacts on India's scientific community. Even more youth will be inspired to go to the next stages. Yes or no? Not only with respect to this, it can test all these things to convey, or we can do microgravity experiments in the mission. Future space-based applications can also be developed. We want to develop into space tourism also. We want to go for other planetary exploration also. Sometimes we want to locate to other planets also in the future. All these things, beginning ship is what? Gaganyaan mission. Space tourism, that is another opening dimension here. What is India's role in it? Gaganyaan will help. It will inspire many. Many technologies will be tested to create human environment or to conduct experimentations there. A plant which is grown in microgravity conditions will give us much more details than if we see them on the plant. So varieties of applications can be developed. Food processing industry, lot of developments will be there. Yes or no? How to store the food for such long times. Already NASA has these technologies. So we will be developing them in different way. Cheaper cost. It will have impacts on various other dimensions. How to generate power in a much more efficient manner. So spillover effects will be there of Gaganyaan in multiple areas. No doubt about it. Apart from that, directly with respect to human space applications, space tourism, future planetary exploration, testing of technology, cooperation with various ministries, various departments, public sector, private sector, R&D, all this will create a good conditions for the growth of space sector. Private company in space also they are developing. Parallelly, we are going in the directions of privatization of space. In India, also steps were being taken in the context of privatization. Antrix Corporation was there in 1992. Yes or no? Then later, recent, you might have heard about NSI, New Space India Limited. Then also, we were hearing about InSpace. What is the difference between these three? Why space is not privatized till now? Why space sector is regulated till now? Why we are privatized? Should we privatize space? That itself is a debate. Okay, because when privatization of space is done, some Ambani or Adani or any big shot will want to have his own satellite. That satellite will carry his name roaming around there. If it crash lands, error is possible, whether it is intentional or unintentional. Yes or no? This SpaceX or this, with respect to this Blue Horizon and all these things that Gundu fellow is doing, if there was an error, who is responsible? Okay, there is outer space treaty. Previously, long back 1960s, there was a treaty. If suppose an astronaut lands, if astronauts land somewhere else, he would be treated as a representative of whole humanity. Okay, if Indian lands in Pakistan coming from a human space flight mission, Pakistan will not ask, where is visa? Go to jail. No, astronauts are what? Representatives of humanity. What about the space tourism? No such things. Private astronauts are very rare dimension. Human space flight. Now that we are going, many things are happening in parallel. Privatization is happening. Human space flight is happening. Why private sector is interested in space? To do research about it. To contribute to know about atmosphere of Earth or what? Is that for that reason is the billionaires investing in space? No. They want to look at this space tourism dimension. Okay. Now India already has the reputation of conducting the things at a very low cost. What if space tourism is also done at a very low cost? Yes or no? Emerging technology. So that is another area where Gaganyaan will venture in. So many dimensions are coming up. Human space. It is more in the context of a pride. India doing its human space flights on its own. Space means about 100 kilometers. So this is one aspect. Why privatization? This is forget about now governing. Privatization of space, when it is being talked about, privatization will help ISRO to focus on research-based things. When other small companies or private companies, they can launch satellites, ISRO can now focus on planetary exploration or mineral exploration or natural resources, many things, rather than launching. Every time a PSLV, a new KU band transponder has to be designed, ISRO resources will be on making that PSLV. You just give it the technology. You work with private people. SpaceX as a private company, when it started, NASA supported SpaceX. Initial launches. Now, SpaceX is supporting NASA. It is launching satellites at a cheaper rate than NASA. That's the reason we are opening up for space with proper regulation. If something crashes, who is there to regulate? That body is in space. Don't confuse with in space and NSIL. NSIL is a company, public sector company, whose main intention is to monetize the ISRO assets. If ISRO launch pad is there, that it will send it to, it will sell like user charge. It will use it for other private launches. Who will do that? NSIL. It will manufacture launch vehicles with the help of private companies. Who? NSIL. It will ask foreign countries, I will launch satellites for you, pay me. That is NSIL. Okay, whereas Antrix Corporation, which was established in 1992 itself, old, this Antrix Corporation will sell ISRO's data. It is also commercial arm, but its role is very limited. Advanced version of Antrix Corporation is NSA. In space is only mainly regulatory body, just like RAC. So it will also enable, it will create the ecosystem. It's more like a regulatory body. So privatization of space is happening. So when privatization of space is happening, definitely issues, critical analysis of privatization of space in India is a simple question, if not in economic, science and tech perspective, at least in economic. Apart from that, we have to actually, why I am waiting for presentations, because this is the main orientation thing. From now onwards, many prelims topics will come. For that, which I have to show, gravitational waves. What are gravitational waves? What is Amazonia? What is with respect to Yarkovsky effect? All these things are there, maybe 1 hour, which will set these PPTs right, and we will see it tomorrow. Okay. So there is another session. I think that is only for mains orientation. You are all students preparing for both prelims and mains, right? There is another batch, I believe, which is focused only on mains. Is it so? Art time batch. That is different, right? Yeah, that may be there in the evening. For us, classes will be in the morning. We'll try to complete space, defense. Then we have to look at nuclear. Then after that, recent development in technology, nanotech, cloud computing, 3D printing, all these things also, communication technologies, that also we'll be looking at. We'll be going only into the examination orientation. Okay, that's it for today. We'll meet tomorrow. Okay. Tomorrow, is it? Yeah, it's okay. We'll cover tomorrow. 9:30 same. We'll try to cover extra. Okay.
Hari Prasad. Today is a bouncer day.
So actually, there is some error showing in this PowerPoint. Name annotations keep discard.
That is okay, we can discard it.
ಇಲ್ಲ resumes.
If you start everything, I think it will work.